Now we need to split out our wall panels so we can start working on those. So we're going to at wall type, and if that is equal to wall, so not wall type, getting into myself, part type. And now we want to loop over those. So for each primitive, we're going to loop over every single primitive and then sort them. And just before I do that, I'm going to do an attribute promote of our part type to a point. Okay. So start filtering through these. First thing I'm going to do is put down a facet and remove any inline points. Just if we've got any stray points that are long here, because we want to get quad grids. And we're going to ignore anything that doesn't have a, isn't just a quad when we convert these into points, a point grid for copying modules onto. So this will just help us get as many of those as possible. The next thing we have to do is make sure our point numbering is consistent for every single panel. So I'm going to start by doing a sort by Y and just doing a reverse. And then I'm going to put down an attribute wrangle and we'll manually work out making sure this is always going around the same direction with the point numbering. Otherwise we'll run into errors when we make out, because we need to make, we're going to convert large panels into point grids, and then we'll need to make a little border around to fill in the extra space. So we want to make sure our border is created correctly every time. So in our wrangle, and I'm just going to call this sort. I'm going to make this a detail, so I'm going to do it once. And then go set point attribute because we're going to make a our own attribute called sort that will use a sort node to sort these correctly. So we'll set 0.1 or 0.0 to 0. And 0.1 to 1. The next thing we need to do is just get our points as they're currently set. And we're going to need 0.0, and I'm just going to copy this 2 times and get 2 and 3. And it's these points down here we need to make sure are consistent. Then we just go and get the distance between 0.0 and 0.2 and 0.0 and 0.3. So we can tell which one is closer, so you can make sure it counts around in the correct direction. So it doesn't go like 0, 1, 3, 2, it'll go 0, 1, 2, 3, always. So just copy that line, switch it over to 0.3, distance B. Then we go if distance A is greater than distance B, and I'm just going to copy these two up here. Two will be 2, and 3 will be 3. Else, two will be 3, and 3 will be 2, meaning we need to reverse it. Then we can put down another sort node. Sort by attribute. And sort. And that should give us they should always go around correctly, no matter what panel we come to. Okay, the next thing we need to do, and put down another wrangle, we need to find any panels that are too small or not square. So group small or bad panels. This wants to be run over primitives. And you're going to steal this line, these 3 lines from there, because that's what we need. Except this needs to be 0.0, 1, and 2 instead of 0, 2, and 3. Now we go at width, which we should have. Sorry, we won't have that. At width we'll be creating right now. So this is the distance between 0.0 and 0.1. We're making that attribute because we'll use this later. And now we need to make a height attribute as well. And again, we'll use this later when we're calculating how many points to add to our point grid. And then we can just minus 0.0 is y by 0.2 is y, and that'll give us the height of our panel. Now let's make a group, so at group, small panel, and we go at width, if that's less than, and we're going to get a channel reference. And the channel we're going to reference is our module size in X. I'm going to times that by 2, then do question mark, and this is just a shorthand for an if statement. So if it is less than 2 modules wide, we'll say it is a small panel, so 1, and then colon 0. Otherwise it's not. So question mark, if it's this, do this value, otherwise do this value. Copy this line, change that to y and this to height. So if it's less than 2 modules high, we also want to make it this. Instead of 0, we just want to go whatever it was set to previously. Okay. In here as well, let's also get basically the excess on the edges to form a border. So we'll have these panels won't perfectly have, say, 3 modules across. There might be a little bit of extra, and we need to make a little border too, so there's no gaps. So I'm going to do uat, which is a vector 2, border dot x equals at width modular our module size x. And modulo this percent sign is just, it does a division and gives you back whatever the remainder value is. So it'll divide our width by our module size, and whatever the excess is, it returns that, and that'll give us our border. Copy that, change this to y and height. And that will give us our complete border. Now one more at group small panel. And we're just going to go in points. First input, so 0. If that doesn't equal 4, so question mark, we'll set that to a small panel or a rejected panel, and then otherwise we'll just keep it at its current value. Colon in there instead of semicolon. Then I'm just going to put down a color. Anything that's a small panel, I'm going to make it like a purple or a pink or something. Turn off single pass. See any of these sort of like smaller panels, it's rejecting. Well, it's not rejecting as many as it should be. So let's have a look at this and make sure I've done it correctly. Okay, let's spot one right off the bat, I did not enter my into this correctly. And also let's just check. Yeah, have not entered my module sizes in here. So that will help a lot. There we go. That appears to be correctly filtering out all of our small or sort of rejected panels. Okay. In the next video, we'll make our borders for these larger ones.